Hi, I'm Ryan Baker, and this is Big Day in Education. Welcome to week 3 of the course, Behavior Detection. So over the last 2 weeks, we've discussed prediction modeling. And this week, we're going to focus on a type of prediction model called behavior detectors. Behavior detectors are automated models that can infer from interaction or from logs whether a student is behaving in a certain way. We've already discussed examples of this early in the class, in particular the off-task and gaming detectors that we talked about in the San Pedro et al. Case study in week 1. The goal of behavior detection is to infer meaningful and complex behaviors from logs or in real time, with 2 goals. First of all, so that we can study those behaviors more deeply. For example, how do the behaviors correlate with learning, and what are their antecedents? And second, so we can identify when they occur in order to intervene. People have detected a lot of behaviors in educational data mining. Some examples include disengaged behaviors, such as gaming the system. We've already talked about gaming the system before in class. It's when a student subverts the properties of a learning system to succeed without learning. Off-task behavior, which we've also discussed, where a student simply goes completely out of the task, for example, talking to their neighbor about Spider-Man. Carelessness, that's where a student knows how to give the right answer, they know the skill, but somehow they're just not paying close enough attention and they give the wrong answer. And also WTF behavior. That stands for without thinking fastidiously. Any other acronyms are complete coincidence. WTF behavior is when a student does something within the system that's just completely inexplicable. For example, when a student's supposed to be plotting points on a graph, they might instead plot a smiley face. Or when they're trying to figure out why a virtual patient is sick, they might take the virtual bananas off the virtual nightstand and take them and flush them down the virtual toilet. There's also metacognitive behaviors. For example, help avoidance, where a student needs help and the system can see that they're struggling and they need help, but they refuse to ask for help. Or unscaffolded self-explanations. For instance, when the software sees the student's wrong and tells the student, "You're wrong and here's why," does the student just barrel along, or do they actually pause, think about it, and read it? Exploration behaviors. In an exploratory learning environment, what behaviors is the student using to learn from this open-ended environment? A third category is teacher strategic behaviors. For example, Mall and Sumner and colleagues have studied curriculum planning behaviors, where teachers are using a system to help them plan out their curriculum, and Mall and Sumner look at the strategies that these teachers use to do that. Or another example would be teacher interventions for students. Miller and colleagues at Reasoning Mind develop systems that can tell when a student is paused, are they paused because they're off task, or are they paused because they're actually receiving interventions from a teacher, where the teacher's seen analytics in the system and gone over to try to help the student learn something they're struggling with. There are a lot of problems related to behavior detection. One of them is sensor-free affect detection, detecting affect, emotions, and context solely from students' interactions with the learning system and no physiological sensors. Now, this is not quite the same as behavior detection conceptually, because in behavior detection, you're trying to infer something that's directly visible in the logs, whereas with affect detection, the student's boredom or frustration is not directly visible in the logs, but it's visible indirectly from their behavior. The methods turn out to be quite similar. It's the same kind of things that you use to develop these models, and we'll talk about this through the week. And people have used these methods to detect constructs like boredom, frustration, engaged concentration, that's the emotion where you're just completely focused on a learning experience, like you are now watching my video, and delight, which you're probably also experiencing from time to time. A related problem is usage analysis for learning management systems and MOOCs. Studying online learning behaviors, but typically not using the same kinds of methods or processes that I'll be discussing in the next lectures. More often, researchers in this area have looked to predict outcomes like MOOC completion or course dropout from relatively straightforward behaviors. And the reason for this is because the log files are often less rich. Instead of having detailed traces of every single thing a student does, every answer they enter, every time they ask for a hint, instead the systems just tell you the student started watching the video at this time and stopped watching at this time, or the student entered an entire quiz at this time. And because of this, we don't have the same kind of fine-grained data, and so we have to use relatively simpler indicators. The kind of things I'll be talking about the rest of this week rely on very rich log data. When you don't have that, you end up kind of more in the space of first week's methods for prediction modeling. That said, there's been lots of great prediction modeling research in this area. Just because we don't have really rich logs in these cases doesn't mean we can't find out really interesting things. And people have been able to predict and analyze a range of outcomes based on when and how much learners use videos, quizzes, labs, forums, and other resources. As for when we'll get richer logs in MOOCs, well, a lot of people are working on that. You may notice in this class that we have assignments where instead of just entering a set of quiz responses and clicking submit, you're actually getting feedback on every single step. And the goal is both to make that a better pedagogical experience for you, but also to create richer logs that we can use to better understand how learners learn from MOOCs.
So for ground truth, where do you get the prediction labels? Behavior labels are noisy. There's no perfect way to get indicators of student behavior. That's why we say it's not truth, it's ground truth. Another way to think of it. In some fields, there are gold standard measures, as good as gold. With behavior detection, we have to work with bronze standard measures, gold's less expensive cousin. Is this a problem? Not really. It does, however, limit how good we can realistically expect our models to be. If your training labels have an integrator agreement of kappa of 0.62, you should probably not expect or want your detector to have kappa of 0.75. Because if you get a better kappa for your detector than your training labels, it means your model is fitting to your coders, not to the construct you actually are looking for. There's a lot of sources of ground truth for behavior. Some of them include self-report, field observations, hand coding of logs, aka text replays, and video coding. The advantages and disadvantages of these methods are somewhat outside the scope of this course. But an important note, no matter which coding method you use, try to make sure that the reliability and quality of your labels is as high as feasible, while at the same time noting that 1,000 codes with kappa of 0.5 might still be better than 100 codes with kappa of 0.8. In data mining, as in many other areas, quantity has a quality all its own. Now, one other thing to note is that it can be harder to get high reliability for video coding than other methods. This might seem a bit non-intuitive because people tend to think it's video, you have it all to see. But in fact, issues of lighting, of camera resolution, of occlusion tend to make it significantly harder to get good inter-array reliability for video than for field coding, for example. In the remainder of this week, we're going to discuss feature engineering for behavior detection and knowledge engineering versus data mining. In the next lecture, we'll talk about data synchronization and grain sizes. I'm Ryan Baker. This is Big Data in Education. See you next lecture.